Okay, well, thank you for the opportunity to come here and present what we are doing with WebGL and why we love it. Let me first introduce our company a little bit to you, because I think you don't know who we are and what we are doing and why we are doing it. So we are a small spin-off company of the university here from this geomatics department, the guys who are hosting this event today, called Innovitas. We were founded just 1.5 years ago and still are based here in this building. Yes. We are active in the business of Stereovision based mobile mapping, and I hope that during this speak here you will get an idea of what this is. So our main services that we provide are 3D City TV, which is a service based in the cloud and uses WebGL to deliver content to the customers. And the second service is Swiss Mobile Mapping, which is more a service for engineers, a very small user group there. This is mostly done on desktop computers, the products there. So now mobile mapping. What is mobile mapping? I'm sure most of you have seen a scene like this, instruments on the side of the streets, and have asked yourself, what is this? Is this the police doing speed controls, or what the hell is this? No, these are surveyors, and they are measuring points on the streets and getting precise 3D coordinates of on the streets. As you can imagine, if you do measurements like this on the streets or even on highways, this is a very dangerous task to do, and sometimes we even have to close down the road so that no cars can pass, and this is of course not a great thing to do and very expensive as well. So people were thinking, how can we improve this? I mean, there must be a way to do this easier, a better way, less dangerous way, and in the early 90s, they started to put measurement equipment onto cars, with the idea behind this that you can go with the flow. You really are on the street, drive with the traffic, and capture your data. And later on, you can measure in this data in your office. So your personnel is no longer at danger when they are measuring. They are sitting in the office and can measure whatever they want. Yes, mobile mapping is not only limited to streets. You can also do it from airplanes, you can do it from UAVs, whatever. But I'm focusing here on mobile mapping on streets because this is our domain we're working in. So different sensors can be used on these on cars. Why are we using stereo imagery then? I will explain this here. Let's take this picture. I mean, for everyone in this room, it is very easy to see what is on this picture. So, for example, you have the situation. There is a sidewalk here in these images. There is a street profile, so you can see lane grooves and even damages in the streets if you take a profile over the street. You can see traffic signs. You can see road markings. You can see street furniture, trees, the road condition, facades of buildings, clearance heights, etc., etc. You could go on like this for hours. No, that's not true, but you have really a lot of information in such an image. And yes, as I already said, a human can interpret these images very well, which is not the case with other sensors like georadar or even laser scanning. Point clouds are really hard to interpret, which is not the case with images. So now you have the reason why we use images, but why do we use stereo images? Well, the great thing about stereo images is that you can measure in these images, and of course, if you go outside and measure things, you have 3D coordinates, and the goal is that you have these 3D coordinates as well when you are in the office. So we have to be able to somehow measure 3D coordinates in the office. This can be done with stereo images. Now imagine a camera can be geometrically be modeled as a pinhole camera, and in a pinhole camera every pixel of an image builds a straight line from the camera's projection center through the pixel in the image into the recorded object. So if you take an image of an object from 2 different positions, you can then measure the same point in the image, or well, the same object in the image, and then get these straight lines which intersect at the object. By knowing now the orientation of the cameras, you can calculate where this intersection point actually occurs. And you can, from there, get the depth of this object. This is important later. I will come back to this depth information later on. So now you're able to digitize features in these images. You're able to generate 3D coordinates in these features. But what are we doing this for? What can we use these gained informations for? Well, our goal, our vision is to integrate this information into a geo-information loop, as we call it. The idea behind this is we go and acquire data. You do now your digitizing in the data, you acquire all the features, you measure whatever you want, and digitize this into a digitized world. This is you save your data in a database, and from there on, the experts, the infrastructure maintainers, they can access this digitized world in their offices, exploit the data, and later on get back to the real world and do whatever needs to be done, what they exploited in the digitized world that needs to be done. So for example, road signs that are no longer visible because of the sun that bleached the image out of the road sign, or if you have damage in the road, everything this can be exploited by the infrastructure managers, and they get back to the real world and fix this. Of course, the loop doesn't end there, because once fixed, you need to re-record all this information again, because over time, all these things degrade, and you need to maintain this infrastructure because it is a very important and very expensive infrastructure. And that is what we would like to realize with this geo-information loop. It already exists, of course, with other geo-information data, but we would like to add the 3D information, the 3D imagery information to this loop. Now let's take a look behind the technology. So what is needed to actually do Stereovision mobile mapping? Well, first of all, you need a platform. You need, in our case, you need a car, but as I mentioned already before, you could also do it from aircrafts, UAVs, whatever you can imagine. We are focusing on cars and also, since this summer, on trains. What you further need, this is what you need on all mobile mapping systems, are 2 groups of sensors. You need positioning sensors and mapping sensors. Positioning sensors, you can see here, they are quite expensive, consisting of a precise GPS or GNSS system. GNSS stands for the combination of GPS, GLONASS and Galileo. And you need an inertial navigation system. So the inertial navigation system is not for the position, this is for the orientation and accelerating parameters. With this information you can get the exact, you can calculate the exact position afterwards of the system, of the images where they were recorded. The other important part in a mobile mapping systems are the sensors. As you now already know, we are using stereo image sensors, but it could also be laser scanners. Most of the systems nowadays use laser scanners, but as I already told before, you know now the reasons why we use stereo cameras. So now with this system you can actually gain the data. Now there are some steps needed to afterwards be able to measure in this data, and this is shown here. First of all, yes, the acquisition. You need to drive on the roads you would like to later digitize on. And then there are some processing steps needed, and these are quite a few processing steps needed. You need to calculate normal images from the images you gain with the mobile mapping system. So you have lens distortions in it and everything like that, and you need to get this out of the images to be able to measure in them. And of course you need to calibrate the cameras so that you know the orientation from the cameras to be able to recalculate this this depth value you have seen before. And then afterwards, depending on what product the user wants, the output of these processing steps can vary. So for mono measurements, you need one image and a depth map, and for stereo measurements, you need these two images. So let me explain a bit what's behind this mono images. As I told before, we are doing stereoscopic measurements, but we can also do monoscopic measurements. If we process before we measure, we process for every image, we process every depth value in the image. So this process of doing this intersection is done automatically in this processing step, and we generate for every image a depth map, which then afterwards can be combined with one single image, and then you are able to measure in this single image. Yes. Well, the products that we can get, I already mentioned before. Most of the time stereo images, but depth maps gaining more and more importance for us, because the stereo measurement is really only for professionals. It's a little bit tricky to measure in stereo images, and with monoscopic measurements you can really access more users, because you can easily do it with a web service. You don't need special hardware, which you also need for stereoscopic measurements. You need special graphics cards, you need a 3D monitor, and this is really not something great for the masses. So the mono feature really is better for the big masses. So again, one image plus depth map for monoscopic measurements, and stereo images for stereoscopic measurements. The navigation and stream data here is used to navigate afterwards in the imagery. You will see this in the demonstration afterwards. Some more words about precisions. You may have asked yourself, how precise are these measurements that we can do in these images? And typically under good GNSS conditions we can reach 3D positions at an accuracy of around 4 centimeters. We can further improve this by doing integrated georeferencing processing down to, I would say, around 1 centimeter. For this is needed sometimes for the mobile mapping engineering projects. Well, just quickly some words about products. I want to go to the demonstration afterwards. As I already mentioned, we have a stereoscopic exploitation client which runs on desktops. It uses the stereo images, and as I said, special hardware, 3D graphics cards, quadro graphics cards only at the moment, and 3D monitors. So this is really something for experts. And the one thing I will demonstrate now, which is our client software that uses actually WebGL, is the the 3D City TV service, which is based on our 3D TV web SDK. As you can see here, this image data really is hosted on the cloud and is streamed on the internet to the client's different applications. These can be web applications, mobile applications, well, embedded applications. This is meant for, this should actually be desktop applications here. I will now demonstrate you one of these web applications, an implementation of a web client here. This was done in Basel, in the city of Basel. And you can see here now image data. You cannot see it, okay. Well, I may have to change here. Okay, now you see nothing here. Okay, great. You can see here now the images recorded in Basel. You can, like in a normal video, you can play forward, and when you see something you're interested in, just stop here. And now let's take a look at this road sign. Okay, now how high is this road sign? Zack, make a measurement. Okay, this is 2 meters. I now would like to make a cadastre with these signalizations in it. So I go to the feature editing tab, click on the sign, give it a name. Okay, and there it is. I can now edit the attributes of this road sign and then export it into my existing GIS, or I can also import data from the GIS into this service. So this then again goes into this geo-information loop. As you can see down here, it's very small now, but this is our navigation interface. If you don't want to always go through the whole videos, you can see here region of interest. Okay, click in it and the service jumps to the position you clicked. We also recorded with different sensor systems, so you can also switch to the left side, look on the left, look on the right side, and then again the other direction. Do your measurements in this image data as you want. I can show you now. Just easy measurement of the street, for example. So I guess I have to finish. If you have questions, I don't know, maybe we have some time left.
Yes, we can have time for questions while we change the laptop. Any
you
questions?
You can ask me later on during the aperitif. Or
Hi. Have you thought about recognizing the images automatically, because the signs, I mean, because it seems like a natural extensions to the system?
Yes, we are actually doing this. Yes,
because you were clicking on the
yeah
thing,
yeah. We have an automatic process for this. That's true, but usually you can get rates of 85% of road signs you can detect in these images, and well, sometimes this can be enough, but if you want 100%, it's really, really hard to do this automatically. So, but depending on the application, yes, this can be done automatically. You can also gain other information automatically out of these images. That's something we're working on.